Hello. So, in this module, we will talk about a very interesting topic in computer organization. And the name of the topic is memory. So, the memory is one of the basic elements of computer architecture that is used to store data for computation or processing. So in terms of a schematic diagram, we can see that the memory has three main components. First one is address lines or address bus. Second one is data lines or data bus. And third one is control lines or control bus. So these are the main elements or components of a memory. Now let us focus upon the one of the component of the memory, that is the address lines or the address bus. So here is a block of a memory inside which you will have the data stored, and to address this data there are n number of address lines of the memory. So as I said, the address lines are used to tell the location of the data inside the memory. We'll get to know where the data is stored by means of knowing what is the address line. So as I said, if there are n address lines, that means you have 2 to the power n memory locations of inside the memory. 2 comes because it's a binary system. So for an example, if I say there are 10 address lines to the memory, that means you have 2 to the power 10, that is equal to 1024 memory locations. So you can also see now if there are 4 address lines, so obviously you have 2 to the power 4, n equal to 4 here. That means total number of memory locations are 16. So here is the address and here is the data stored that says you have a particular address number ranging from 0 to 16. In fact, it is 0 to 15. And in each of the memory location, you have some form of a data stored. So the table of memory looks like this. Now let us talk about the second element of the memory, that is control lines. So you have n address lines already in the memory, and then you have 3 control lines: read, write, and CS. That stands for chip select. So we'll see what is the function of each of these control lines. So the chip select is used to enable the chip for the operation. To perform the operation, you want to first activate the chip. So if chip select has 0 or 1, depending on the logic, your memory gets selected or deselected for the operation. Next is write enable or WE, or simply say write. It allows when you want to write the data inside the memory. Third one is output enable or OE, or in simple terms, you call it as a read enable signal. This control enables data to be read from the memory. It is opposite to write function where you actually write the data inside the memory. Finally, we have covered address lines. We have understood 3 control lines, that is read, CS, and write. Now, the final one, we talk about the data lines. So you have n data input lines to the memory and you have n data output lines. The data lines tells us, or data lines are used to transfer the data to the memory and from the memory. So you want to put the data inside the memory, you actually perform the write operation, and during this you have transfer n data through these input lines inside the memory. However, when you perform read operation, it means you are reading the data outside the memory, so through these n data output lines. So that's why the data lines are used for. So here as an example, you have a memory with 8 data lines. It means this memory has 8-bit data input lines and 8-bit data output lines. So at a time, you can transfer 8-bit data to and from the memory. In other words, you can also say you can transfer 1 byte of data at a time to and from the memory. Remember, 8-bit means 1 byte. So there is one important aspect now we will see, and we will talk about the data which is stored inside the memory. So data is stored inside the memory is called as word. So this is the basic unit of data inside the memory. It consists of fixed number of bits. We'll see how many bits are there. So first we understand bit means 0 or 1 because it's a binary system, and byte is a group of 8 bits. So you can have the word stored inside the memory, that is a series of bits, and if it is 8 bits, you see that 1 byte of word stored inside the memory, or 1 byte of data is stored inside the memory. So there are 2 to the power k words stored inside the memory, or k number of locations, or n number of locations. Okay. And in each word, you have x bits per word. So if you have like n number of address lines, you can say 2 to the power k words are stored inside the memory. So for example, when you have a 32-bit memory, and it means it has 32 bits of one word, or 4 bytes per word. Okay, if you say I have a 16-bit memory, it means it has a word of 16 bits, or 2 bytes per word. Remember, 1 byte is 8 bits. So now let us talk about what is memory size and its organization. You can see now this table shows locations and this table shows a data. So memory size is given by this formula, that is equal to number of location multiplied by data per location. So if you say I have total 2 to the power 16 locations, means, and you have in each locations you have specific word stored, let's say 2 bytes or 4 bytes. In this case there are 2 bytes. This 1 byte is of 8 bits, this 1 byte is of 8 bits. So you in each location you have 2 bytes stored, or 16-bit data stored. So you can say now this is a 16-bit memory. So you have 2 to the power 16 locations right over here. And the size of the memory is again with this formula, that is number of locations multiplied by data per location. So 2 to the power 16 multiplied by 16 bits. So that's why 16-bit. So total size of the memory is 1 megabyte. So this is the architectural representation of a modern memory, where you have address decoder logic, which is used to decode the address lines. If there are n number of address lines, for example, 3 here, so 2 to the power 3 would be total 8 output lines of this decoder that are used to select at a time a one particular location in the memory, through which you can read or write the data to and from the memory, provided you enable the memory by means of activating this chip select signal first. And once you activate the memory through this and you perform the read or write operation accordingly through this data bus, as you can see the bidirectional arrows, the data is transferred to and from the memory. So we got few very important facts and a basic understanding about the modern memory in the computer architecture through this module. I hope you found this model useful. If you did so, share it with others. Stay tuned for more engaging content like this. Till then, wish you happy learning.